Good evening, ladies and gentlemen. Welcome to the second lecture hosted by NUS Cities. For those of you who don't know about NUS Cities, we are a university-wide, multidisciplinary, open and inclusive, collaborative platform hosted within the College of Design and Engineering. Through our collaborations with local and international institutions, we hope to create synergies that extend within NUS as well as beyond NUS. NUS Lecture Series hopes to investigate ideas, policies, and projects developed by urban experts which aspire to create sustainable, resilient, and livable cities. We will be inviting professionals, practitioners, and academicians from universities, private practices, and international institutions. Throughout the series, we hope to create a platform for discussion, retrospection, and conversation to give momentum to the ongoing research and exploration regarding issues concerning cities. Now I would like to introduce the first speaker of the evening. Professor Bregje is the Scientific Director of Deltares, a Dutch research institute for water management and a senior expert in nature-based solutions. She's an associate professor at the Delft Institute of Technology in nature-based solutions for climate adaptation and disaster risk reduction with a focus on marshes and mangroves. She strives to both strengthen the scientific foundation as well as further practical applications of nature-based solutions. At Deltares, she has over 15 years of experience in working with development banks, the UN, NGOs, and governments in Asia, Africa, US, and the Netherlands, for whom she provides advice on flood risk reduction, erosion mitigation, and climate change adaptation. As Scientific Director of Deltares, she chairs the Science Council, which advises on quality and direction of the work of the organization. We now invite Dr. Bregje on stage.
Thank you. Hello, everybody. Well, it's impressive. This is Dutch dinner time, 6 o'clock. So impressive you're all here. Well, I'm very honored to be here, to be honest. I've only been to Singapore once, 10 years ago. And it was really nice. It's my first travel since COVID, actually. So, or outside of Europe then. And I'm enjoying actually the city and to see how green the city is. And I think we could learn something about that in the Netherlands, actually, in the way of building and including the natural forests and trees in the city. So, can I skip? Does it work like this? Yeah, there we go. I can skip through this. So today I will talk about nature-based solutions, which is a topic of my own work and research. The question is a bit, can nature be our solution to climate change? I think we all know it is the solution, right? I mean, both to mitigate CO2 emissions, but it will also help us to adapt. And what we are seeing globally is that we see more intense events in terms of flooding. So this is the Netherlands in the summer of 2021. We got a rainfall event that I think this is what happens to the Netherlands if we get a rainfall event that resembles the rainfall event you are facing here. And this was in the southwest. Most of the rain actually fell in Belgium and Luxembourg, but it flew down the river towards the Netherlands. We had in the Netherlands no fatalities, but in Belgium we had over 100 fatalities. But we had severe flooding, and what we realize is we're facing events that we're not prepared for in the Netherlands, that are more intense than we used to see, and they may occur more regularly. So it means something for our water system, for how we work with our water management system, which I think it basically applies for all countries in the world. And this is the other side of it. So we face more intense rain, but we also face more intense drought. So this was in the US. They invented a new term a couple of years ago, like flash drought. And we're seeing that in the Netherlands also. We had 2018, 2019 were two of the driest summers ever. So while we face more intense rainfall in shorter time, we also face more intense drought events. So we also need to, while we're all very much focused on discharging water, right, getting rid of the water, there's another need. We need to retain more water as well. And then with sea level rise and climate change, this is of course one of the things that's happening. I think about over half of the coastlines in the US is right now already facing erosion. Erosion is one of the events that is more like an indirect consequence of sea level rise, and it's not been properly mapped yet, so we don't even know what happens, but and how severe it is and where we see it. But you see, we're facing now multiple compound events, and I want to phrase the last IPCC 6 assessment that basically made these statements. They say the effects of climate change are already visible. And besides mitigation, we also need to investigate adaptation, because how much we can mitigate, even if we would mitigate maximum, we also need to adapt already to these effects that we're already facing. And they also said the adaptation that we currently do is basically incremental, meaning that we do what we already have been doing and we just add to it. So we have been building levees and seawalls, and then we think what we are going to do, we just make them a little bit higher. And they say what we need in adaptation is transformational adaptation, which means we really need to rethink what we are doing. And we need to come up with different methods of thinking, different ways. And they also, for the first time, emphasize the role of nature. So we cannot adapt or mitigate while badly influencing nature, because we have another other crisis. We're in the worst ecological crisis and in the worst area of biodiversity decline since we're on Earth as humans. So I always say we can, in a carbon neutral way, still go towards a path where we're not able to live on Earth anymore. So it's not only about planting this type of single tree species. We need to also think about biodiversity in the meantime. So big challenges, and the IPCC just stressed these. And I think one of the fields that I will talk about today is how do we transform our infrastructure systems to include nature? And this field is also called nature-based solutions. There's a big rise in publications on nature-based solutions since the beginning of the 2010 to 2014. So the topic is more popular than it ever was. But I think what it also needs is systematic research in how we can better work with nature and how we can integrate it in our infrastructural way of thinking. This is a graph that is basically showing a sort of continuum from gray solutions towards natural and green solutions. And what we always say is it's not about a single solution for every hazard or type of risk. You use a full portfolio of solutions. So it's not one or the other, but likely it's a combination. And today I will focus a little bit on those combination or on the hybrid solutions that are in the middle, where you use a combinations of maybe traditional or engineered flood defense systems with the ecological system. And I think there's a big merit if we there start to integrate better, and if we use the functions that the ecological systems that are often already present along our coastlines can provide, such as reducing wave impact, reducing current velocities, trapping sediments, right, to accrete with sea level rise. So one of the other challenges if we start thinking about infrastructure and if we want to transform our infrastructure thinking, I think is this. I think the new infrastructure that we will invent should be multi-objective. What we see, for example, in river management, if we start managing for a single objective, we always find other objectives that are neglected. So for example, I have been working a lot in Indonesia, the Philippines, and there's a practice of straightening rivers, also upstream. So they cut all the meanders and they straighten the river, but basically what you do is they push the flood downstream. So if you only manage for flood risk upstream and manage in this way, you only manage for discharge, you actually shorten the path of your river, you lose a lot of your ecological functions, but you also get more severe problems with drought because you don't retain your water and you reduce the time that the water has to infiltrate. So multi-objective is one of the challenges, and to deliver co-benefits. So nature is very good at delivering co-benefits like recreation, tourism. So if we're able to include it, those co-benefits will come automatically. And this is one of the examples where in the Netherlands we tried to really do it different in river management. So we had a room for the river program, and basically we said we had 2 flood events in 1995 and 1996, or it were near flood events. And then we felt, okay, we need to do something to actually be prepared for these higher water levels that we see more often. And we said we're not going to raise the embankments along the river, but we're going to use measures to increase the space for the water, and that in that way to reduce water levels. So we used other measures, like here we dug a side channel, we moved actually people there, we created a new neighborhood. So here is a bypass, but we also widened the river plain. I have other examples of this program. In some areas we deepened the river plain. So it was, and here what we also did is we included those other objectives also as an evaluation tool. So we said a measure that we implement should lower water levels, but it should also fit in the landscape or provide aesthetical landscape value or ecological benefits. So evaluating these other objectives, actually this program gave us as the Netherlands a big win in in the ecological status of a river and in nature. So the other thing is basically to serve multiple hazards at multiple scales. So multiple hazard means we need to manage a river for both droughts and floods, and not only for floods, right? Because then we may increase the effect of droughts. And at multiple scales. So it means not looking only at the area where we work, but also looking upstream and downstream of a river. And if we talk about cities, for example, because this is a Sustainable Cities lecture series, every city is based somewhere in a landscape. It can be a coastal city, it can be based in a river basin, and measures that you do upstream in your river may influence your flood risk downstream. So if you straighten your river upstream, you're going to push your problem down if you have to a downstream city. So basically this is about, and if I build upstream dams, I'm going to reduce the amount of sediment import to the coast downstream. So I may face coastal erosion. So the importance of assessing interventions as multiple skills, I think should be part of transforming how we think about infrastructure. And that means also, for example, longer timescales. So looking at adaptation at longer timescales and doing your cost-benefit assessment in a different way. Not only looking at a small area, but looking at a bigger area. Not only looking at 5 or 10 years, but maybe also at 25 years or 50 years. And if we start doing that, it will also be easier to include nature and natural benefits, because they sometimes take longer to actually start up. So if we look along coastlines, because I'm going to talk a little bit more about coastlines, I decided to stay close to my core, and I also thought at Singapore you're really good at urban management, so I'm not going to tell you anything about urban water management, but I want to tell you a little bit about coastlines and vegetation along coastlines and along rivers basically, and how we can work with it together in hybrid interventions. So we did this analysis of the green is marsh vegetation, so that's along temperate coastlines, and yellow is mangrove vegetation, and we found that about 20% of global coastlines contain vegetation, and that also their vegetation plays a role in reducing waves and wave impacts, which means vegetation there plays a role in reducing flood risk and reducing the risk on erosion. So these are what we define as hybrid options. So it's basically you have the water level, and there you have a part that is like a foreshore area, which can consist of a mudflat or intertidal area, and then of an area where you have vegetation, and then a levee and an area where there's exposure, right? Assets or people And if we look at that vegetation, what it can be is, well, here in Singapore it's mostly mangroves. You do have some marshes like you have in the temperate zones, but you also find some marsh areas in the back of mangroves sometimes, and along rivers we find this kind of floodplain vegetation. So there are 3 types of vegetation that we're focusing on: freshwater, and 2 saltwater types of temperate climate and of tropical climate. So one thing about these hybrid nature-based solutions and including vegetation is that I think many people still think, and I hear people say, that they think it's uncertain to use it. And I find it interesting because I think it increases certainty and it increases reliability of your flood defense system. So for example, if I have a hybrid system and I have vegetation in front of a dike or a seawall, first of all, that vegetation traps sediment. So if I have gradual sea level rise and if there's enough sediment available, my foreshore will be able to accrete and grow with sea level rise. The other thing is, if I have an ecological system there and it is eroded, I mean, it's an ecological system, so it's dynamic, so it can erode and it can grow, but it can also self-repair. So it means, as ecologists, we know that if the system is large enough, if it's biodiverse enough, that it is resilient to disturbances. So if there's a storm and it gets damaged, it is able to actually regrow and regenerate. And the third part of resilience is that the vegetated system works different in attenuating waves. So vegetation, independent of the wave height that comes in, reduces waves non-linearly. So a large wave is reduced much more rapidly than a small wave, which means that after vegetation stretch, I end up with the same amount of smaller waves. So it's less dependent of the type of wave that comes in, because they all get reduced to a similar wave if your vegetated system is long enough. So that means that if I have a combined or a hybrid system, that with changing sea levels or changing wave conditions, for example, it doesn't matter that much and I don't need to upgrade my levee immediately. I have some more. And also, when gray coastal defenses fail, so this is an analysis that we did with a group of researchers, and it's very interesting because it got started by a historian. So he found maps of one of the biggest flood events in the Netherlands in the end of the 19th century, I think. And he found these maps, and these maps indicate where you have levee breaches during the storm event, but they also indicate the areas where we have salt marshes. And if you look at all these maps, it basically showed that the number of breaches in the graph left, oh wait, I can do it like this. So the number of breaches and the width of the marsh, so you see if the marsh becomes wider, the number of breaches in the levees are a lot lower during these flood events. So the marsh protects the levee actually against breaching. And we found the same, we also looked at total breach width, and you see if the marsh width increases in front of the dike, the width of the breach is a lot smaller. We also did some modeling exercises, so basically the marsh creates more stable soil, and you don't get the deepening effect once you have a breach and the flow starts coming through it. You don't get the deepening and the widening of this breach so rapidly with the marsh in front. So the hybrid defenses are also nice when they fail, or when the hard defenses fail. So basically the question is, for these hybrid nature-based solutions, can we design them well, right? Can we construct them? So besides we have nature there in many areas, but in some areas we don't have it. So then the question is, can we design with it? Can we design both the soft and the ecological part and the hard part together? And can we construct them? So basically I think construction is restore the ecosystem that used to be present there. And can we manage them? I'm not going to answer all these, but this is basically what my research centers around. So, and also what we try to do in this research is, you see it after each tsunami and typhoon, you see these things in the newspapers. Basically, we don't want to make false assumptions, right? So we don't want to say, oh, that's great, those mangroves, go live behind it, you don't need a seawall. Don't do that. I mean, you do need a seawall. Mangroves don't stop water. They just reduce currents and waves, but it doesn't block, right? It still flows through. So safety first. Okay, the clue already is we can design because we already did it in the Netherlands. So maybe just to show that initially. So this is a hybrid defense that we constructed. It was a room for the river project, so it was one way of actually widening the river plain in this area. This is one of the Dutch rivers. Here, the levee used to be here, like it used to go like this, and then like this, straight on. And what they did, they created like a gully here. So with high water in a river, the water is going to flow in here, and actually it's partly flooded here. And then what they needed to do, because they breached the levee here, they needed to lengthen the levee like this. And here in this area, there was an old fortress. And the people in this area said, we don't want a high levee in front of the old fortress because it's high-end real estate. And then we thought, what can we do to help them? And we made a hybrid solution. So this is the new levee. And it's more than a meter lower than it would be without the vegetation in front of it. We planted willows in front of it. So the willows take care of the waves, and then the wave height at the toe of the levee is designed at 10 centimeters wave height at the toe of the levee. So this is really implemented, and the wave, do I have it here? Yes. This is one of the things we use for design, so we use numerical modeling. And basically here you also see, so here's the incoming waves, and in this area with high water levels, they can be over a meter. And this is the wave reduction without vegetation in front. So then I would end up at the toe of my levee with a wave of 80 centimeters. But if I put vegetation there, you see it is reduced and I end up with 10 centimeter wave. It runs here over through the forest of willows. And what you see also that third principle I said about reliability, independent of the wave height that comes in, all waves after 100 meters of vegetation, they are about 10 centimeters high. And when we did this numerical model, I have to say we didn't really validate it yet. It is the standard way of modeling that we use right now in vegetation modeling, right? So it was, I think this was SWAN. We can also use it in XBeats. It used the Mendes and Losada wave model with vegetation in it, which is based on a vegetation model of Dalrymple, which is vegetation is represented as a rigid cylinder. So it's not vegetation, it's actually some kind of stick. So we thought we need to improve reliability of these kind of predictions, especially if we will design more with it. So we had a lot of extra safety with that levee, but extra safety also is extra costs. So basically we said what we right now use for the numerical models are measurements under very mild conditions. But what we want to design for is often very extreme conditions, right? Like a 1 in 10,000 year event or 1 in 4,000 year. So we try to make this loop. We have field measurements, but they are often from mild conditions because people don't go out in the field during a tsunami or typhoon. I don't know many field measurements of waves that are over a meter. So most measurements for mangroves are waves of 20 centimeters. So the question is, can we translate that to numerical models and then assume that there's a wave of 1 meter high? And I mean, is a mangrove bending, and is it bending in a different way under a high wave than under a 20 centimeter wave? And a 20 centimeter wave is with 1 meter water that runs through the stems, but with 4 meters water, it may run through the canopy that behaves different. So we want to know all these things by going through this loop and then also by doing large-scale experiments under extremes so that we basically get information on this. What happens with these types of forests under extreme conditions? Because after tsunami, you don't see this in the media, but this is what a mangrove forest may look like. So when a 7 meter high wave runs through it. So basically we want to know when does it look like this, when does it break, when does it fail, and can we improve the predictability of how it attenuates waves and surges and long waves and short waves. So this is what we are also working on. We want to reduce the uncertainty for the failure mechanisms of the trees and get more insight in when the trees fail and how much width of mangrove, for example, do I need. I now focused on trunk failure and branch failure and not on uprooting mechanisms, but we're also investigating that. So this is what we did. Basically what is lacking is measurements under extreme conditions and controlled measurements. So where you have multiple water levels, multiple wave conditions, and where you also have a control when there are no trees but only a platform. So that is so that we can sort of distinguish between the effect of the bottom roughness and the effect of the vegetation only. And where I work at Deltares, we have this wave basin, and it can make the highest artificial waves in the world. So I think I should at least use it for my research now and then. And it is perfect to test these more extreme conditions and vegetation. So this is what we did. We started with willows, and I bought some willows from somebody who grows willows in the Netherlands, and they want to get rid of all trees. So these trees are 15-year-olds. They brought them to Deltares, and then we planted them in little boxes first, till they sprouted again, because this was in winter. And then they sprout again, and then we put them in this big wave flume. And we made a sand cover first, and then we put trees in, and then we topped it off with concrete. So we're not looking at uprooting here. We wanted them to be stable, also because such an experiment was never done, and it's rather costly. So I was extremely afraid that in the first wave, one of the trees would fly out, and that we could drain again the whole flume. So this is what it looks like. So this is when the whole, if you go back, you see, whoo, don't do it like that. Oh. You see that there's a stem, and then there's like the canopy. So this is a pollarded willow, so we cut it each year. And the branches here are not cut for 3 years, and the stem is 50-year-olds. And we raised the water level to 3.5 meters, and then till 4.5 meters. So with the 3.5 meter, the water level is in the middle of the canopy, and that is here. And now I have to see if I can play it. Does it work? Yeah. So you see. Yeah, and we measure, of course, in front of the forest and behind the forest. And behind the forest, there's a dike. So we can also measure run-up on the dike. We measure that to see if the forest effect run-up. And what you already see is the branches do move, right? So they are not like rigid cylinders. And moving also means that the dampening effect may be less. And this is with, what we did is because the Dutch, it's not public works, it's Rijkswaterstaat, they wanted to know how do they perform in winter, so when there's no leaves. So we had 15 students leave the trees by hand, and then we tested it without leaves, that's here. And here's the 4.5 meter water level. Without leaves, and those are, I think, some of the highest waves we tested. And look here what happens to the branches. You see the branches, they bend almost 180 degrees with high waves. So that really changes the effect of the reduction capacity of these trees. So it's not. So it also means that I cannot use a small-scale test and just for a mild condition and translate it to an extreme condition. So what we, of course, did is, maybe the results. So what we saw, the reduction of the wave was strongly dependent on the height of the wave and the length. That's not new. We already knew that. But it was one of the main results. And we say the wave reduction is strongly dependent on the water depth relative to the distribution of the surface area of the tree. Because if I have a lot of surface area and the water depth is exactly there, of course, the damping is most. We saw no breaking of branches, but that's also because they're flexible, right? If you're flexible, you're not going to break because you bend. It's bend or break. We had waves up to 3 meters in the end, so there was a maximum wave height, not the average. And what we see, what happens in the numerical models, if we start looking at it, is that there are 2 uncertain factors. That is the drag factor, which is basically also a representation for the bending, and the surface area of this tree. And we see the plant surface area is often underestimated. So we use this work also to look at the numerical models, and we, on the y-axis is the drag factor, and these are other studies, and this is the KC number, but this basically means these are mild conditions and these are extreme conditions. And you see there's those other studies, there's no measurements for the extremes, and you see this factor should be 1.2, like for laminar flow. And it does show that here, what does it show? Mainly that you cannot randomly calibrate your model by calibrating with the drag. You shouldn't do that. The drag shouldn't rise above 1.2 or something, because there's no physical basis for it. And we basically show that if your vegetation bends under extremes, the drag is more like 0.7. And the other factor, I'm going to be a bit quicker. I'm looking, I'm fine? Okay. What we did then, actually, we 3D, so is it here? Yeah. We did use terrestrial laser scanning and hand measurements to map the full forest and the surface area in each and every tree. And this is also a result that this complex tree, it should maybe not be represented like this simple tree in a model, because then you underestimate the whole surface area of the tree. So we actually made this whole forest and we terrestrial laser scanned it. So this was exactly what it was like in the flume. And then, now this is work of my PhD student, and I should click like this. And she 3D printed the forest in a 1:10 scale. So now we have it in a smaller scale, and we can do the same tests and see if we get the same results, and also if we get the same bending. And then we can do more tests than we've done before, but we can also play with other factors like the flexibility. What happens if the trees are more rigid? And then we can measure real trees like mangroves in the field and determine the elasticity modulus, for example, and then put them in the model again. So that is what we now try to do. A lot of work. The future work that we do is actually improve the insight in the effectiveness of nature-based solutions under different conditions. So with climate change, it's really important, if we want to implement these solutions, that we really know how effective they are, not only for swell waves or shorter waves, but also for long waves and for surges and for current reduction. So that is what we're working on now. Also, we want to improve the insight in a full range of failure mechanisms. So also the geotechnical mechanisms like uprooting, root breakage, and of course the forces that they experience when they fail, so that we know with what hydraulic forces they are going to fail. Another important thing, we want to assess long-term stability and resilience of these systems. So looking how wide should they be, how much dynamics can you then expect, on what terms in time. And all this work, I think, should in the end work towards developing guidelines for design and for development of these type of solutions. And finally, working on MBS restoration and management methods. And I think this is also extremely important, because this field leans heavily on ecological restoration, right, of these ecosystems. And I think also here is where ecologists and engineers should come together. Like this field, engineers should not start redoing the hundreds of years of ecological restoration that are already out there. So we should use that knowledge that's largely already there. My future work will be with mangroves. So mangroves don't grow in the Netherlands, it's too cold. So we put them in a greenhouse. So I'm growing them in a greenhouse now, and I'm aiming to put them in our wave flume in September of this year. But we have to see what we will exactly do. If we put all the trees in or one, or we do forces on a single tree, what we find scientifically most interesting maybe actually one tree, and then measure everything on a single tree and the exact forces. I'm going to finalize here. I think important for good nature-based solutions, look at the whole system. All these elements interact, right? The sandbar, the mangroves that are protected by the sandbar in front, the river that brings in the sand, the waves that throw it back to the coast, the gradient of mangroves that's here, and the city that actually benefits from the protection of this system. But I cannot look only at the mangroves because then I forget what is protecting the mangroves. So this is why it's so important to look at the whole system and zoom out. And for me, the most important is always we try to work to this together with engineers and ecologists. And because there's a lot of innovation and things to gain, I think, and for this field, we need to learn from each other. Thank you. I have to say, I didn't do this all by myself. This is the team that helped, and that is PhDs and postdocs and other researchers.
Thank you for this amazing lecture. It was really nice to see the kind of work which is being done. Welcome back, everyone. I would now like to introduce you the second speaker of the evening, Professor Stefan. He's the Professor of Coastal Engineering at Delft Institute of Technology in Netherlands, as well as the Chair of the Department of Hydraulic Engineering. He's also the Director of the Foundation EcoShape, Building with Nature. He holds a PhD from TU Delft and previously worked for Delft Hydraulics, now known as Deltares, as well as in the dredging industry. His research interests include monitoring and modeling of nearshore coastal processes, dredging for marine infrastructure, and building with nature to ultimately enable broad implementation of nature-based solutions in daily engineering as well as management practice. Through his 25-year career in the water sector, he was closely involved in execution, programming, and management of applied coastal research, always at the interface of science, engineering, and design.
Thank you very much. Thank you very much for this kind introduction. Let me start by saying that KLM has been so kind to leave my baggage back in Amsterdam, which is the reason why I'm dressed here nearly as a tourist, but I smile. And it may be like this for another day or two. We'll see whether they perform. I have to say it feels relaxed, so I'm enjoying it now, but it is a bit of a hassle. That's worse. Secondly, my name is Stefan Aarninkhof. I'm Professor of Coastal Engineering at TU Delft. I have a big interest in nature-based solutions. And today I'll be talking about the implementability of nature-based solutions in practice. And how can we create an environment, and that goes broader than the physical environment or the ecological environment, that suits for the implementation of these nature-based solutions. Now, that story will be mostly from an EcoShape perspective. I'll get back to you in a second what EcoShape means and what it is as an organization. Before doing that, I'll say a few words on Delft, the city that we're all very familiar with, at least the Dutch people who are here in the audience. And it can be a bit confusing because even within Delft, I mean, the Netherlands is not a big country, but even in a single city, we have many organizations who all do things slightly differently, but also work together a lot. And within Delft, we have 3 institutes that are heavily involved with water issues. The first one is Deltares. Bregje talked about that already, the work they do. They're often involved with contract research type projects. They also carry some responsibilities towards the government in maintaining specific enabling technologies, specific models, for instance. And also if it comes to emergency situations, they are advising the government what to do. Then secondly, we have TU Delft, that's where I work. It's a university, so we always combine education and research. And actually, sometimes if university would stop working, I think the companies would find it more problematic that we no longer deliver students than that we stop our research. So what I'm trying to say is that education is really important for us as a university. The research we do is often a bit more fundamental than the work that's been done by Deltares. So it's a bit more in-depth, and it's supportive to the, let's say, the contract research studies that are carried out by Deltares and other organizations. And last but not least, there's IHE Delft. Ab van Dongeren is working there, besides his appointment at Deltares. They have a bit more of an international orientation. Students from all over the world come to IHE Delft to study hydraulics, also to do a PhD, and often afterwards they go back to their home country and to bring the lessons that they learned to its practice. So it's 3 institutes, all slightly different, but also with a lot of common. We share lab facilities. We have a lot of dual appointments. Bregje is a good example. She works both at Deltares and at TU Delft. I worked at Deltares for 10 years in the earlier phase of my career, so there are a lot of cross-links. We work on projects together, and we do research together. And one thing that we all like, of course, we all have an engineering orientation, or many of us have an engineering orientation. We like interventions. And that means that if you do an intervention in a natural system, you try to achieve a certain objective, for instance, guarantee safety against flooding, but always in the most sustainable and smart way, so to say. If you want to do a responsible intervention in such a natural system, it always starts with a sound and fundamental understanding of the natural system at hand. So those are the two piles where we often start working. Understanding the natural system and understand how to design an intervention and what is the impact of that intervention. Now this is an example for climate change. On the horizontal axis you see time scale, and this is very long. It's a bit uncertain, but it's decades to centuries, so hundreds of years. And on the vertical axis you see an indicator of climate change. That can be sea level rise or the rate of sea level rise, which is important if you work with natural systems that grow with sea level rise. And here in the lower left part of the graph, that is today's situation. The pace of sea level rise is not very fast yet. We know it's going to become faster in future, but for the time being, it's still modest. And that means that nature-based solutions can play a very good role in keeping up with sea level rise in the decades to come. In some situations where it does not work, you need man-made interventions. It's not that one is always better than the other. It's always a site-specific and a local solution. On longer time scales, when this pace of sea level rise goes up to maybe 10 millimeters per year or 20 millimeters per year, you may start thinking about larger scale interventions. If you want to continue living in the way we live nowadays, then you need larger scale interventions in these systems in order to ensure coastal safety, but also fresh water supply, for instance, becomes an issue then, and also accommodating the water that comes from the rivers. There are many plans available. This is just one example. And on the very long time scale, there are even wild ideas, closing off the North Sea. This is probably not realistic, but these are worst case scenarios that are being considered. Maybe the very worst case scenario would be to accept that sea level rise is there, and we have to leave the western part of our country and step back from the sea. This is sort of a continuum of solutions that need to be explored, and it's important to explore these quantitatively in order to be enabled to make sound judgments. For today, and actually for most of the research that I do, I focus on the lower left part of this picture, on nature-based solutions in combination with engineered structures, if and where necessary, because I feel that these are the best solutions for now and also for the decades to come to develop our coastal systems in a resilient and a sustainable way. And this is where we work a lot. We have a lot of PhD students at TU Delft who work on topics in this green circle, often in collaboration with other universities and other partners. But I'm not going to talk about that today, because today I'm going to talk about my second role, and that has to do with EcoShape. I'm the director of EcoShape since January 1st of this year. And EcoShape actively works on the concept of building with nature. And building with nature essentially means the development and implementation of nature-based solutions in water systems. It's an approach to realize, to design, and to implement climate-resilient infrastructure. And EcoShape is a very special organization. It's an open network, a network of parties that actively work together on developing these nature-based solutions and bringing them to practice. And what makes this network special is that this is a combination of private industries, of consultants, of research organizations, of universities, of NGOs, and of governmental institutes. So all the parties who are involved with infrastructure development are engaged in this foundation and actually invest in this foundation in order to develop the knowledge that they need to create and to build these nature-based solutions. Now, if you want to do that, you have to agree on a few special arrangements. One important one is that you have a shared ambition, namely building these nature-based solutions. Secondly, what helps is that you have a very tangible approach. We work on field cases, on pilot programs, because it turns out that in order to have a good multidisciplinary cooperation, it helps if you work together on a specific field site, on a specific pilot program, with very tangible objectives and goals. Third, what is important is that we focus on pre-competitive knowledge. The moment that you enter into the competitive domain, individual parties start fighting, and the atmosphere of cooperation is gone. So it has to be pre-competitive before a project gets on the market. We develop that pre-competitive knowledge in an open manner. It's shared within the consortium and also to the outside world. And as long as every partner feels that he is better than the other partners in applying this new knowledge in practice, you're in a good situation. And that works. We never learn for the project at hand, but we learn for the next project. That means that you need to understand the underlying coastal processes, the underlying physical and ecological processes. So there needs to be a sound scientific basis for the work that you do. And last but not least, and Bregje mentioned it already, the new knowledge will be translated to practical guidelines, and more and more importantly becomes the upscaling and mainstreaming towards practice. A pilot, it often starts with a pilot, but what you really want to do is scale up to a project in reality. This organization has been out there now since 2008, so quite some time now. The motto of the first program was show that it works. We developed new stuff, and we wanted to show that these new applications worked in practice. After that, there was the motto, make it happen. So we know that it works. How are we going to make it happen in practice? And since we just started the third phase, we're still looking for a good motto, but it will be something related to system impact of individual interventions, something like that. And then in a nice word, work in progress. By mid-March, we hope to know more. Now, just an example how this works. This is an example from the Netherlands. This is actually quite a special dike. This is a dike that separates water from water. But you need to know that to the left, which is to the west, 30 kilometers to the west, there is the city of Amsterdam. So if this dike breaches, Amsterdam has a problem. And for that reason, we had to reinforce this dike. Traditionally, this would have been done with concrete and asphalt, so a grey solution. But in consultation with ecologists and other stakeholders, we decided to test whether a green solution could work here. And therefore, a pilot scheme was being developed. And that's the small-scale intervention shown in the upper left part of the picture. So what EcoShape did is they took the initiative to develop this pilot. They actually built it, commissioned by the government, and we monitored it for a period of 4 years. And after 4 years, we felt we had learned enough about sediment losses, about the safety of the dike behind, about the vegetation development on this new land, that the pilot was evaluated as successful, and that was a starting point for the implementation of the full-scale project. So this small-scale part is the EcoShape innovation part. This is a simple commercial project, procured in a regular way to the market, and so on. Right? And the knowledge gained from the pilot was shared with a big audience. That worked quite well as a stepping stone towards practice. So building in nature, what is it? Well, in short, it is to develop infrastructure and at the same time create benefits for other functions of natural systems like nature and society. And if you want to do that, that's quite complex because it comes with uncertainties, it comes with multifunctional objectives. It is still fairly innovative, and it's always local and context specific. So if you want to realize these solutions, you need to think, to act, and to collaborate differently. And that's something we try to learn. And we learned that mostly from a whole series of pilot projects that were carried out over the last 14 years. There's a nice book nowadays. Chang, we had a spare copy here, but not here, I'm afraid. Huh? There is a nice book, and we can show it later this week, where all these concepts are being developed. And There are different categories of pilot projects that we developed over the years. The nature-based flood defenses, the sandy one I showed over here, but also the type of defenses that Bregje talked about with mangroves and with willow trees protecting the dike behind. There are the resilient delta cities, not that many examples so far, and mostly focusing on the waterfront. So the interface between the water and the city. We are less active, I have to admit, and I realize what audience I'm in here, but we are less active in the truly urban setting, I have to admit. That has to do with a partnership that has developed this EcoShape organization. We are active in ports, particularly in the beneficial reuse of wet materials, and we increasingly work on ecosystem restoration. That's an interesting one, actually. Whereas in the old days, often there was a safety problem, and we said, okay, can we think of a solution that comes with benefit for nature? Nowadays, we more get the question, hey, we want to carry out an ecosystem restoration project. Can we do it in a way that it brings benefits for the safety of the hinterland behind? Different way of thinking and an interesting market, probably. So, nature-based solutions. If you follow the media, you sometimes think that there are common practice already. We see it in magazines in the Netherlands. We see it in the promotion material of NGOs, and you see it actually in all sorts of policy documents who talk about nature-based solutions. They all promote the use of nature-based solutions in water systems, but for some reason, the true upscaling and the true implementation in practice is still a bit challenging. It's not happening too often. Now, why is that? And this is the book I just talked about. EcoShape made a very thorough analysis of that. And we concluded that there are 6 factors that play a role, that are crucial for successful implementation of nature-based solutions. Now, the first one is a trivial one, technology and system. I come with examples, by the way, where these factors play a role. But this is a trivial one, technology and system knowledge. If you don't know how the system works or how to make your design, then you're lost already up front. But the other ones are equally important and probably a bit more surprising. Stakeholder engagement is important because we come with new and innovative solutions. If you do not engage the stakeholders from the first day onward, the new solutions may not get accepted, and hence that can become a barrier for successful implementation. Management and monitoring is a key enabler to be able to manage uncertainties that are often inherent to nature-based solutions, since they are dynamic and evolve over time. Institutional embedding is an important one. Often nature-based solutions are multifunctional. That may mean that different departments, different governmental departments, different agencies are being engaged, are being involved in development and implementation of a solution. That comes with new challenges. The business case is not always straightforward. Many people think that nature-based solutions are more expensive. Sometimes that is the case, sometimes it's not. But to build a business case is a topic of research and will actually be an important one in EcoShape 3 as well. And last but not least, capacity building. Develop the momentum and the young generation who is adopting these type of solutions and is willing to bring them to practice, including all the efforts that come with that. Now, a few examples. Sand motor is an icon of building with nature, probably one of the first. In the Netherlands, we have a lot of sediment. So I realized that some of the examples that I show are a bit sediment dominated. But the principles, the underlying principles, are very similar to situations elsewhere in the world. This was a solution where a big sand nourishment, a big hump of sand, was put on the coastline to protect this coastline for 20 years, for a period of 20 years. And in that period, the waves and the tides would distribute the sand along the coastline rather than man-made machines. What was crucial here is that this solution was not projected all of a sudden, but there was a long phase before where all stakeholders in the area were engaged in developing this type of solution. So no one talked about the sand motor, no one talked about a big hump of sand, but they said, hey, we have an ambition agreement where we say we want to do something new, and it should protect the coastline, and it should create 70 hectares of new dunes along this part of the coastline. So it was a very open process involving all the stakeholders to arrive at this solution. That was a prerequisite for success in this case, and an innovative approach. Here's a mangrove example from Indonesia. It has received quite some press, and it actually won a big award earlier this year, or late last year, to be honest. Very prestigious. The idea is here to build brushwood dams to create a sheltered environment where sediment will settle, and in those sheltered boxes, new mangroves will grow and widen the mangrove belt in front of the shoreline, so that the shoreline is better protected against big waves coming in. An innovative project that had many different phases that had to be realized in order to make this happen. A key one was the multi-stakeholder approach, where local communities were really engaged in adopting these new solutions, also maintaining these new solutions in order to turn them into a success, not only for the pilot situation, but also along much longer stretches of coastline as they were developed later on. This is an example from the Netherlands. Well, I won't talk about the details of what's happening here, but the idea was if we use a traditional solution, again, it would be a simple dike reinforcement. Then an NGO came in and said, hey, there is ecological value to be gained here. I think the project sum was in the order of 50 million euros. The extra costs for adding the natural component, the nature component, was in the order of 10 million euros. Those were covered by the NGO. That made the business case, and it's in that way that this project could be realized. So why is this important? Different money streams had to come together, which is not trivial as we all know, but it was the enabler to make this project happen in the most nature-friendly way. And well, you cannot read these numbers, but we made an analysis from practice, considering different projects where nature-based solutions were being applied or actually were being implemented, and we made an analysis, hey, what would be the cost of the project without this nature-based component, and what are clients apparently willing to pay extra to achieve a true nature-based solution. And as you see then, these are in the order of, 200,000 euros, 100,000 euros per hectare new habitat as a ballpark figure. Well, that is something you can keep in mind. This is for the Dutch situation. Interesting analysis. Handling uncertainties, monitoring, the blue one, management and monitoring. Example from the Middle East, but applicable anywhere in the world where strong environmental requirements are applied to hydraulic infrastructure projects in execution. You can only do that if you can demonstrate that you're not harming the environment. So that's where real-time monitoring comes in. And also the work should be carried out in an adaptive way. And sometimes you even design the project in an adaptive way so that you can change it throughout the execution in order to make sure that the local ecosystem, can be a coral reef or a seagrass meadow, is being preserved throughout execution. And this is an interesting one. This is a very simple example from Portugal. This is Lisbon, so the capital of Portugal. This is the River Tague. The river needs dredging, and traditionally the sediment would simply be picked up here, sailed to deeper water, and disposed into the ocean. So essentially the sediment was gone. Well, the simple solution is not to dispose it at deep water, but bring it here on these eroding beaches, right? It took them 6 years to embed that in law. So this was not a technical problem. It was entirely straightforward. It was cheaper, but this was simply a institutional problem. It was not allowed. The laws had to be modified, and in the end they succeeded, of course. But it took some persistency, so to say. Please.
Where is the nature-based component?
Oh, it's a good question. The nature-based component is that, first of all, that we want to actually maintain the sediment into the system. So rather than dredging it here and disposing it at deep water where it's lost, you want to maintain it here on the coastline. And secondly, by nourishing the coastline, you get a more natural coastline than a coastline protected with all these structures. Ideally, we can almost cover these coastal structures with sand to turn it into a natural beach again. Therefore, we call this a nature-based solution. Yeah, good question. Well, and last but not least, capacity building. So you will work with nature. We want to let students feel what it means to work with natural processes. Therefore, they do field work. This is at the sand motor on the Dutch coast. And this is also something that's very much supported by industry, so that we educate students who know the forces of nature and who are willing to go out into the field and make these solutions happen. How am I doing time-wise? Still good? I'll speed up a little bit. So these are all enablers, right, for implementing these solutions. Once solution is there, there's often an upscaling potential, and this upscaling potential is often less trivial than you may think at first glance. This is quite a specific project. This is called the Marker Wadden in the Netherlands. Here's the same dike again that I talked about earlier, and this is a big lake, so it's not a very dynamic area. The water quality in this lake, this is a 30 by 30 kilometer lake, the water quality in this lake was not very good, which is the reason why one of these NGOs decided to take the initiative to construct a new set of islands, and they are being developed as a bird paradise, as a paradise for birds. It was really meant to create new habitat for birds to feed and to rest, and at the same time, the idea was that this group of islands would trap sediment, so that sediment was taken from the water column in the lake, and in that way the water quality in the lake would improve. So suspended sediment concentration would go down, light penetration in the water column would go up, organisms at the bed of the lake would revive again. So it would be an overall improvement for the system as a whole. That was the idea. Fairly specific, given the low energy conditions. But still, there is upscaling potential. And it's important to realize, if you want to apply the lessons from one project at a different site, never copy the project as a whole. Right? So do not simply take the Marker Wadden and put it at an arbitrary location somewhere else in the world. That goes wrong. Still, this is done every now and then. So be aware, but don't do that. But look at the underlying principles, the concepts that are relevant. And in the case of the Marker Wadden, elements in this approach, important elements in the approach are the strategic placement of fine sediment. It engages with the construction of nature islands, restoring ecosystem connections. That has to do with the birds in the area. It's about the creation of sedimentation basins. That was actually quite a challenge to build these natural islands with poor quality sediment. The design criterion was that a goose should be able to land on it without drowning. So goose, of course, don't drown, but it had to be stable enough that the goose should step up. It's about integrating foreshores and developing these wetland areas in this specific context. And there are several projects where this knowledge could be applied. This is an example from the southwest of the Netherlands, Waterdunen. This particularly related to this is a tidal area, but it's managed, so it does not have the full tidal cycle as it would have with an open entrance. Important here is that different functions come together, different stakeholders come together, and all together resulted in a very different solution than we would have got otherwise. Also, the blended finance structure is an interesting element here, which was an enabler for the project, like for the Marker Wadden, by the way. An interesting example from the UK. This is the River Thames. This is close to London. Again, a river that is subject to maintenance dredging. Back in the old days, the sediment would have been sailed to the North Sea, where it was essentially lost from the system. Next to that river were a series of former mining pits for gravel. Very deep mining pits, 40 meters deep or so. Very poor ecological quality. So it was decided to use the sediment from the river to fill up the mining pits and to create a new wetland area for the birds. This was done in cooperation between a contractor and the Royal Society, the British Royal Society for the Protection of the Birds. So an interesting collaboration between an NGO and a contractor. Together they applied for the license, and together they realized the project. Very interesting. Another example where lessons from the Marker Wadden can be used to develop these sort of islands in the sheltered areas. This is an example from the US, where they have a 40-year plan to develop these islands and to create a sheltered zone for the city behind. And an example a bit closer to here. This is in the Yangtze River, Chongming Island, close to Shanghai, which is positioned, which is actually developed as the most ecological island of China. And what they do is here they use Dutch material from the river, which is I think 60 million cubic meters per year, in order to strengthen the wetlands over here of Chongming Island, rather than using it for land reclamation. This is meant for nature restoration. So EcoShape. What EcoShape does is not so much working to make these projects happen. That is a commercial activity. But EcoShape tries to deliver the knowledge that is needed in order to enable these projects, right? So we focus very much on the generic research that is needed to make this happen in practice. And we're at the onset of phase 3 of the program. A bit stronger than in the last few years. We're going to focus again on pilot cases, on living labs, on field labs. And we hope we can develop a field lab together with Singapore in due time, since you have a very interesting environmental settings here, very different from the Dutch settings. Given the tropical climate you have over here, much less sediment, much more hybrid solutions, green-blue solutions, that entirely serve as nature-based solutions where we can learn a lot and where we can probably also help a little bit, I hope, based on the experience we have from these general lessons that I presented. Over the last years, there has been a lot of focus on building up the building of nature community. We're not going to throw that away. We're going to continue that, of course, by means of thematic tables that interface with the sector, that explain about the results that we have, and also bring back the relevant questions that are out there. And there will be a continuous focus on knowledge dissemination and capacity building. Now, this is the example that I talked about already. You're more familiar with this picture than I am. I copied it from a report by CLC that was published last year. Very interesting report and a very nice overview of where different type of nature-based solutions. You see there, these are very different from the ones that we're used to in the Netherlands. Where different type of nature-based solutions are already been applied in Singapore at this moment, and there's probably room for expanding on this. That's about it. Thank you for your attention.
Thank you so much for this inspiring presentation. We are now open for questions from the audience.
All right, thank you. That's really great work by you. So I have, if possible, I have one question for each speaker. So first for Prof. Wesenbeeck. So my question is that, so we know mangroves are great. They're so great in damping waves because they have very complicated root structures, and their leaves also contribute. They're evergreen trees. So of course they're really great, right? But they also are kind of limited because they only grow on muddy substrate. For some region, so for example, if the substrate is a little bit sandy, and also some people would like to enjoy a sandy beach, right? So for those regions, do you have any insight into what kind of nature-based solutions can be implemented if it's not mangroves?
Yes, thank you for the question. I think you're right. Mangroves grow best in the muddy environments, to say like that, or mostly in sheltered environments. So you do have some areas, right, like an atoll area where you have like a ridge on the beach by coralline sand, and then you have the mangroves behind. So you also have more peat-based mangrove species. And I think what I always notice is around Asia that people are very fond of mangroves, but they're less fond of the beach forest. But that is the forest system that belongs with the sandy environment, right? So there are trees that are a bit like mangrove trees, but I think for the sandy beaches, there's the beach forest ecosystem that has some overlapping species, but also some different species that are also, some of them are rather threatened because often they get removed also for tourist resorts or that like to be in the front. So that is the ecosystem for the sandy coast.
Thank you very much. So I have one more question for the second speaker, Prof. Aarninkhof. So I would say all the projects are great. You're using nature-based solutions to trap sediment and reserve the sediment from being washed away to the open ocean, right? And those are all really, really good. For Singapore, I think one challenge that we have here is that we don't have enough source of sand. Right, sand, they come from mountains and boulders, they break into smaller particles, and we got sand from the runoffs, right? But I feel like in Singapore, this might be a challenge that we don't have enough source. So if that is the case, what would be if we still want to use the similar approach, what would be the best way to do it?
Yeah, that's a good question. I'm fully aware of that, and that's actually that's one of the reasons why the examples that are shown in the report by CLC, they look quite differently, and I understand that. So investigating these hybrid solutions, the combination between green and grey, I think it's a very interesting way forward. And another important step to make there is to start considering the impact of these solutions, not on a local scale but on a system scale. I was at a conference in Sydney in December, the ICC. Some of you were also there. At that meeting, and there was a lot of talk about these living seawalls program where Singapore is also informed, and I think I'm not sure whether it was developed here initially and then made a step to Australia or vice versa, but both countries are very active there, and it's interesting to see what these local measures do on a local scale, but does it help on the let's say on the 50, 100, 200 kilometer system scale, right? I think that's an important element to study. If it comes to the use of sediment, we have to be careful indeed with all the sediment that we have, and one of the things that we think about, maybe for testing here in Singapore, is whether we can use dredge material, which is not suitable for building purposes. So I mean, if you're addressing sand, you want to use it for different purposes. But let's say the finer material, maybe we can use that to strengthen mangrove areas, which would otherwise not grow in such a fast speed, or help them to grow with sea level rise. The ultimate goal is not to lose any sediment grain, right? But that's not straightforward. But that could be a nice goal, to make sure that we use every sediment grain that we have to the best use.
Thank you so much.
Hello. Hi, my name is Abhi. I'm a senior researcher in NUS. I'm actually curious to know, what is your approach when you get any kind of a project? Like, you go to the stakeholders or governments approach you, and then you say that, okay, here should be like a paradise for the birds, or you want to reclaim this land and make some other things, or instead of the high rise you want to create these kind of mangroves, or how do you approach to a particular solution to a specific place, like you showed in Indonesia, or governments really ask you to do something with respect to what the site needs, and like based on a SWOT analysis, what kind of problems a particular site has. So I'm more curious to know about your approach towards nature-based solutions.
Good question. I can probably do another talk of an hour about it, but I won't do that. But I think one of the approaches we use is like a planning approach, right? So that is, there's a lot of planning approaches for flood risk management. There's a policy cycle, and we wrote in one of those documents, we wrote a planning approach for nature-based solutions, and it has steps. So we use a stepwise approach, but for example, I adapted it for ADB to fit their project cycle. So it should be fitted for each government specifically, probably, to fit it. But for nature-based solutions, what we start with is in a pre-feasibility phase, is the system analysis. So we look at the natural system, the geology, the hydrodynamics, the ecological system, the morphological system. Then we do look at we make a sort of risk assessment, right? Looking at hazards, looking at the exposure, what is exposed. So it leans heavily on risk assessment also. And then you go look at the stakeholders, what stakeholders are involved, what are the objectives. What I notice in many projects, and it goes for any project, also regular infrastructure projects, that a very important part is the setting of the objective. Because the objective is determining whether my project succeeds or not, or what I want to measure, or who's my client, but who are other stakeholders? Do I give them also an objective, right, or not? So if I have a single purpose objective, that's what I a bit said. I think you should make multiple objectives, make them really smart, and then, yeah.
My question was more towards developed and developing sites as well. Like for the developed nations, maybe the EU governments are already, well versed with the situation. And I don't know about the Indonesian project that he showed that how much you have to push the governments or have to deal with the stakeholders that if there should not be any commercial developments of high-rise. So how much consciousness?
Yeah, but we start with the natural system, same in Indonesia. So we start looking because in Indonesia was a bit different. We wanted to test the approach of the hybrid structure. So we went a bit from a technological, we want to test something. We start looking from the natural system, where is there coastal erosion? So we did this planning process, then we talked to the local people first. So we had another area closer to Jakarta first, and then the people said, because there's land ownership issues, right? So the people said, do you want to restore the coastline? Oh, my fish pond has been eroding. And then we said, we restore it. And they said, who will benefit? Can I make it a fish pond again? We said, no, we want to keep it mangrove. And then they said, so then my neighbor benefits, we don't want it. And then we moved somewhere else, close to Semarang, and we again talked to the community. There was coastal erosion, that was the first criterion. Then we talked to the community, and the community there said, yes, we would like to host a project. Then we went to the government, and we talked to the Ministry of Marine Affairs, and they said, we find this a really interesting approach. We have money for mangrove restoration, which means planting mangroves. We allocate it to your project. So that's how we started, and then we wrote a lot of funds.
But it's important to do it that way.
But we had the government involved from the beginning, sorry.
Yeah, it's important to do it that way, because what's different for these nature-based solutions is that they are dynamic by nature, and it's not something that you build one time and you leave it out there for 50 years and it serves as expected. No, it needs maintenance. And for many governments, that's not always trivial to guarantee maintenance for the next 50 years or 25 years. And also communities are often involved in that maintenance, so that is something that you really need to discuss up front. Otherwise you build a nice project and it will fail within 2 or 3 years if this part has not been well organized. And the other thing I like to stress, and Bregje started to say, that attitude is important, so an open attitude. I worked with Boskalis for 10 years, and I mean, never do this with engineers only. I'm an engineer, so this is a compliment. But what happened to Boskalis, we had a new tender on the table, we saw the solution within 15 minutes, and from that moment onwards, we focused on that solution only. And the key to success here is to keep the process open. Do not think in terms of solutions too early, but first indeed define the objectives. What is it that you want to achieve? Consider different broad solutions, and then slowly iterate towards the best solutions, which can be completely different from the one that you had in mind initially. And the good thing about engineers is that they're very focused and very problem solving and do a great job. But if you do that too early in a process like this, you may not end up with the best solution. So you need an open approach, especially in the beginning.
Thank you for your presentation. So, Professor Aarninkhof, at the beginning of your presentation, you showed the slide that was a bit scary in the sense that you were showing like a slide that was showing the scale of the change. I think there was the time on the x-axis, and then you were showing the place of those nature-based solutions were in the lower left of your graph. Yeah. And then on the higher end, there was migration. So my question is, what is the role that is it just a transition solution or a temporary, and it means that no matter what, after 20 years they are submerged and you need to rebuild? Or what role can they play in the longer term?
That's a very good question. I think that nature-based solutions come with a lot of advantages, especially at the moment where we are right now, in the sense that they can help us developing our coastal zones or our water systems in a sustainable way, guaranteeing both safety and other functions. So it's a perfect solution. Having said that, we also know that some of our natural systems will fundamentally change if climate change is taking a different shape. For instance, if the pace of sea level rise, if that's accelerating, which we expect will happen in the second half of this century, at some point the capacity of a natural system to grow with that sea level rise is no longer possible. For instance, the Wadden Sea, which is a sheltered sea in the north part of the country with a lot of fine sediment, it's a great area for birds. It's probably the most important area we have for bird nesting and bird feeding. But we know already that if the pace of sea level rise becomes 10 millimeters per year, parts of the Wadden Sea will drown. So in that sense, there are limitations to nature-based solutions in the long run. The point is, the timescales are largely unknown, because the uncertainty, the prediction of sea level rise are, I mean, in the Netherlands they vary between 40 centimeters to a little above 1 meter for the next 100 years, and the most extreme scenarios go way up, but they are high risk, low probability. So given that bandwidth of uncertainties, I think it's wise to start with adaptive solutions like the nature-based solutions at this very moment, especially since they add so much quality to the system. But we have to be aware, depending on how climate change evolves over time and what are timescales associated with that there may be a limitation to the use of nature-based solutions. So that's why I project it in such a scheme. But if I had to advise the government, I would focus on the lower left part of the country. Lower left part of the picture, sorry.
Thank you, Professor, for the presentation. And I'll jump on what you said at the end. If you were to advise to the government, because if I remember one of your first slides was all the stakeholders of the eco-shape. Yeah. Maybe I overlooked, but most of the private sectors were mostly on the service providing side. And as a global trend now, we're always advised, even for social projects, to try to engage the private sector. So I was wondering if you see both an opportunity and a clue on how to bring those private partners more on the demand side, because I guess as a society, but even as stakeholders, they all have to suffer more and more for the avoided cost that you would expect from nature-based solutions. Yeah, that's a. If you say the word service providing, I interpret that as there is a request from the government and someone is being hired to answer that request, right? Yeah. I think, at least in this context, these industrial partners, and these are big dredging contractors and also the consultants, have become a bit more proactive in the sense that they want to develop these solutions themselves to, let's say, to serve the world better, but also to be part of the development of these new solutions. And I think that's a very wise thing, because they bring in knowledge that no one else has on the execution, the feasibility of these projects. Well, let's be honest, sometimes they also bring in money, which helps to realize programs like this. And also, if they are being part of this development phase, the likelihoods that these solutions are being adopted in practice is also growing. So the innovation cycle is speeding up dramatically. So I think, personally, if you manage to set up a cooperation like this, an open cooperation, co-creation by different parties, open exchange of information, and also transparent process, then it can be very beneficial for the development of these sort of new solutions. But it's indeed not in the classic role of client-contractor, so to say. It's more interactive than that.
Yeah, I think also because we feel with these type of innovations, I mean, at some point maybe the government can want it or ask for it, but if you haven't taken along the private sector and they cannot provide it, then it will stop anyway. So you need to develop these new solutions together.
I just have a very simple question. Do you think that the marine carbon credits will actually self-pay all these measures?
The carbon credits?
Marine carbon credits.
I don't, right now it doesn't work that way. I think often the government has already claimed the credits, right, for the system that's there. Like if it's a mangrove, then the government probably already submitted the credits and the carbon stored with the mangrove. And we are looking, but not for the payment scheme, but more into one of the omissions there in research is if I would restore a system, for example, so there's a degraded mangrove, and then I make it into a healthy mangrove. I think it's very unknown how much carbon is stored then in degraded forest, because that may be a lot if the soil is still intact, you know, it depends on many factors. And what can I then account as the additional carbon if I restore a mangrove forest? So that is still unclear, yeah. Yeah.
Good question, yeah. Oh, you have to run all the way up.
Question. You mentioned just now that you feel that nature-based solution is more certain and robust. Can you qualify that a bit more? Like certain against what? Because we know that there's still uncertainty in how you model trees, like hence the research. There are uncertainties in climate projection. So when you mean certain and robust, what was that compared against?
Well, I mean, yeah, it's a very good question, because I said it, but also there are uncertainties. I think also because we're not used. Is it my thing? Oh.
We should not get too close, I think.
Because there's also uncertainties, right? Because especially from the engineering perspective, we're not used to working with it. We're very well, I mean, it's sort of like we have to, for the nature-based side, they have to conquer like 100 years of engineering experience and then sort of keep up to that level of knowledge. So it's, and plus engineers are engineers, so they're less familiar with the natural system. So I think there's uncertainty in working, and it requires a different mode of working or collaboration. And it also, like the enablers that Stefan showed, I mean, you need to then interfere at all these levels, right? Also institutionally, in financing schemes, in deduction schemes, all these kind of things, in risk perception, in stakeholders, in mosquito, in plagues. So there's a lot of additional new things that then come. So I think that is where the uncertainty is. We are in a fixated system that is very optimized, and now we're transferring to a new system, basically, which actually increases uncertainty also. But I think for the natural part, maybe also to refer a bit to the long-term perspective, what we realize in the Netherlands is with the polder system, we have moved ourselves a bit in a lock-in. So in a lock-in situation, because once you start interfering in your system, you keep on interfering because you always have something else to manage. And the water, we are currently revising the whole way we do water management, basically, because we had the polders, we were pumping, but next to sea level rise, we have several areas that subsided for meters due to the water management that we have by the pumping. So we both have the peat that oxidized, so we lost meters of peat, and we have the clay that actually consolidated because of the pumping and getting the water out. So we're now transferring our water management by saying, okay, we have to increase the water levels in many areas, and we're actually start doing that already. Also to stop carbon emissions from the peat systems. And I think where nature is definitely more resilient is it doesn't move you in this lock-in that we're in now, because with the levees, the polder systems, at some point in time, we don't know when, it's ending. I think we're fine maybe with 5 meters sea level rise, you know, but with 20 meters, nobody's going to invest in the area like the west of the Netherlands with 20 meters sea level rise, basically, I think. So the answer is in better management of the natural system and in not like lowering the soil table, right? So we're now starting an innovation program, very likely, to increase again, to see if we can increase our land level again. So by accumulating sediment. So sediment, we still put it off into the deep sea. Are we crazy? It's a resource. We face coastal erosion everywhere. I mean, we should keep it close. So we want to grow land by sediment, and we want to initiate peat formation again to actually increase our soil table so that we can start increasing the water table again instead of keeping it or lowering it. So that is what I mean with, in the long term, it will be more resilient if we are able to better manage it and work with the natural system.
No more questions?
Oh, I cannot move that way.
Okay, so actually that works out perfectly in terms of time. We would really like to thank Professor Stefan and Dr. Grant. Thank you so much for showing these amazing presentations and sharing your valuable time with us. Please do watch out for emails and the social media for our upcoming lectures. Thank you and good night.